The content of the unit. Alright, so conversions are a big part of what we're going to be learning in this unit. Okay? The main idea of this unit is to get to a place where you can do stoichiometry. The main idea of this unit is to get to a place where you can do stoichiometry. And that includes being able to do conversions properly, setting them up properly, doing molar ratios properly. Okay? The first place I want to start is converting from the number of moles of a substance to the number of particles, or the other way around, vice versa. Okay? The number of moles of a substance to the number of particles, or vice versa. Alright? And that conversion is always exactly the same. The equality statement, I'll say the conversion is, the equality statement for the conversion is always the same except for the species. Okay? And the main number you need to know is something called Avogadro's number. 6.02 times 10 to the 23rd. Okay? Particles of anything. Is equal to 1 mole of that thing. And there's a movie out right now called The Thing. Maybe some of you went to that this weekend. I have no idea. I didn't go see it. I don't plan to go see it. I know it's kind of a sort of a remake or an update of an old black and white movie called The Thing.
And what's this called?
Avogadro's number.
Can you spell that?
Avogadro.
V-O-G?
A-V-A-G. Excuse me. Excuse me. Avogadro's number. Page 3 of the unit handout. Seems like it would have been one of those things that you highlighted or put a box around or something when you annotated. Just seems that way to me. Okay? Good. I'm proud of you. Okay. Now, this is an equality statement, but it's not specific enough for our purposes. For our purposes, instead of saying particles of anything, we want what anything happens to be in this particular case. So let's say I have 27.5 moles of carbon dioxide. Okay? And I want to convert that into the number of molecules of carbon dioxide. Okay? Well, then the first thing I need to do is write the appropriate equality statement for this problem. Now, in previous problems, when we were in Unit 1, I always gave you a statement somewhere in the problem so you could figure out your equality statement. Okay? That was your training wheels. You're past that now. You're going to be figuring out in this unit your own equality statement. Okay? Now, this is the easiest one of the bunch, folks, because if I'm looking to change moles into particles, I need to know in my head that there are 6.02 times 10 to the 23rd particles. In this case, molecules. Molecules are particles. Molecules of CO2. Now, molecules are not the same thing as moles, so don't try to put a shorthand MOLE instead of molecules. They're not the same thing. Okay, it's equal to 1 mole of CO2, and this is the shorthand for mole. You can spell it MOL. The original name was, I think, German, was actually spelled like that. This is the English version of that word. Okay. Now, using the things you learned in Unit 1, you know that you should be putting your starting amount over 1, and you should build this conversion unit so that we have the same units and species on the bottom here as the starting amount over here. Well, the side of the equality statement with the same units and species is this side right here. That's what I'm going to put on the bottom. 1 mole CO2. On the top, then, I'm going to put the other side of the equality statement, 6.02 times 10 to the 23rd molecules of CO2. Okay? Now I can cancel the like units and species that are on the top and bottom. So moles can cancel out, and CO2 can cancel out because they are like units and species on top and bottom in the same multiplication division problem. Okay? This is multiplication and this is division. Okay? So now we're ready to write our answer, and I'm going to kind of skip past this down here to put the answer down below. So this kind of is sort of set off here. That's our equality statement. Okay? So I need my calculator.
Whoa. Yeah, 82. Old school.
There you go. So this is, our numbers are across the top. Therefore, we're going to multiply. All right?
When do you divide?
20, whenever you have something on the top and something on the bottom. 27.5 times 6.02. Now I'm going to help you out here because these calculators have a really nice sort of shorthand for doing these complex scientific equation type of, scientific notation type of numbers. What I want to do is this second double E on my calculator. Yours may say E or double E or 10 to the, you have to kind of figure that out. And that E means 10 to some power. So all I have to do is put in the power now.
Can you show us the buttons?
Okay. There's my double E button is right here, but you have to hit the second button and double E. Okay? Other calculators do it a little bit differently, but you have to figure out the syntax for your calculator. All right? Now, just to be careful, I'm going to go ahead and put this in parentheses to make sure there's not any kind of syntax confusion. Okay? Since this is a multiplication problem here and an exponential problem here, and I'm multiplying by this just to make sure the sequence doesn't mess up the calculator as far as giving the answer I want, then I'm going to put that part in parentheses. Okay? And I hit enter, and there's the answer I should get. Okay?
Why do you have 2 dashes?
What 2 dashes?
No, like, that means equals. I didn't know. Yeah, it's okay. I thought the same thing. That's the same thing.
Okay, so there's the numerical answer. Okay? We need to round this answer off to match the digits in our problem. This is a counting number. Okay? You're not going to use this 1 here, and you're not going to use this 1 here for figuring out significant digits. In a multiplication division problem, you use the total number of digits in the number, measurement or calculated number, that has the least digits. There are 3 least digits here and 3 digits here, so I need 3 digits in this answer. So I underline these last 2 digits in order to keep these first 3. Okay, I need to have my units and species. I've canceled out everything but molecules of CO2. Okay, and now I need to round it off. 1.66 times 10 to the 25th molecules.
Wouldn't it change the 23rd since you take off 2 decimals?
No. No, that would change the order of magnitude. Okay? And put a box around it so poor Mr. Tedder won't be confused about what the correct answer is. Okay? Got it?
Got it.
All right. Now listen, I'm going to give you a homework problem to do. One homework problem. Just one. Just one.
One's more than none, but less than 2.
Okay? The homework?